When we think about self-driving cars, we usually picture them getting smarter, faster, more powerful. But what if the real secret to making them safe isn't just about being aggressive, but also about knowing when to back down? Today, we're going to break down the two big ideas that keep these cars safe, what I'm calling the spear and the shield. So let's start with a bit of a riddle. What if you have a car that is, by all measures, working perfectly, but it's still the most dangerous thing on the road? Imagine this, a self-driving car. All its sensors are online, the code is running just fine, but it's pouring rain. I mean, a total downpour. And the car's camera just can't see that truck up ahead through the sheet of water. See, the car isn't broken, but it's completely blind. And that's the massive challenge engineers are tackling right now. Believe it or not, this problem actually has a name. It's called SOTIF, that stands for Safety of the Intended Functionality. There's even a whole standard for it, ISO 21448, which is basically the rulebook for handling these kinds of perfectly working dangers. And to solve this puzzle, engineers have two main playbooks. One is super aggressive, and the other is super defensive. Let's start with the first one, the spear. This is the all-out offensive strategy. The idea here isn't to shy away from a problem, it's to smash right through it. It's about building a system that's so smart, so strong, and so aware that it can take on all the messy, chaotic stuff the real world throws at it. Okay, so a car's biggest weakness? It's often its eyes, the cameras, the sensors. You get some rain, mud, salt from the road, and poof, your billion-dollar car is effectively blind. The spear strategy says, nope, we're not just going to accept that. You fight back. You have to engineer ways to keep those eyes clean, no matter what. And the tech they're using to do this is just awesome. Check out Vallejo's Centricam. It's basically a little lens cover that spins like crazy, literally using centrifugal force to throw water and dirt right off. Then you've got companies like AutoSysEng that use these powerful, targeted jets of air to blast debris away. And here's the brilliant part. That same air jet also helps cool down the sensor. It's a perfect two-for-one solution. But the spear isn't just about physical hardware. It's also about making the car's brain way, way smarter. Instead of just reacting to problems as they happen, the system can be upgraded to actually predict and shut down threats before they even become an issue. This is so cool. A car can use its GPS, the exact time of day, and the date, and plug all of that into an astronomical algorithm. It's called an ephemeris. It lets the car calculate the exact position of the sun. So the car can basically think to itself, okay, in 20 seconds when I turn this corner, the sun's going to be right in my camera's face. And before that even happens, it can adjust the camera settings or decide to rely more heavily on its other sensors, like LiDAR and radar. Now, that is playing offense. The car's brain also has its own internal checks and balances. So modern cars use this super powerful deep learning AI, right? It's amazing at spotting things, but it's also kind of a black box. We don't always know how it makes a decision, and it can get confused by stuff it's never seen before. So as a safety net, many cars also run older, simpler algorithms like one called HOG that just looks for basic shapes. It's not as powerful, but it's super predictable. So if the fancy AI says all clear, but the simple algorithm says, I see a blob that looks kind of like a person, the car knows to slow down and be extra careful. And the last piece of the spear strategy is all about communication. It's not enough for the car to know what it's going to do. It has to broadcast its intentions loud and clear to all of us, pedestrians, cyclists, you name it. And you're already starting to see this out on the streets. Mercedes-Benz has these special turquoise lights that switch on when its drive pilot system is engaged. That color is a universal signal that says, hey, the car's driving itself right now. And on the audio side, you have BMW, who literally hired the movie composer Hans Zimmer to create sounds for its electric cars so that these whisper-quiet vehicles actually have a distinct audible presence. Okay, but you can't always just muscle your way through every problem. Sometimes the smartest and safest thing a car can do is just admit defeat. And that brings us to the shield. This is the defensive strategy, the philosophy of knowing your limits. You could almost call it engineered humility. Designing a car to know what it can't do and to retreat safely when it hits that wall. And a perfect, simple example of this is a single number, 3.5 Newton meters. That is the typical maximum amount of force that a lane-keeping assist system is allowed to put on the steering wheel. So why that number? Because it's weak enough that any human driver can easily overpower it. It's a built-in leash. If the system makes a mistake and tries to swerve, you can always grab the wheel and yank it back. It's a physical shield that keeps the human in ultimate control. Another huge part of the defensive strategy is what I like to call shrinking the sandbox. The fancy engineering term is reducing the operational design domain, or ODD. Basically, the ODD is just the list of conditions where the car is certified to work safely. Certain weather, certain roads, certain times of day. If things start to get dicey, the shield strategy says, make that sandbox smaller. And this is happening right now. In San Francisco, if it starts raining too hard, Waymo and Cruise robotaxis just stop. They stop taking new passengers and guide themselves back to the depot. They know their sensors can't be trusted, so they take themselves off the field. The same logic applies to programming them to avoid a notoriously messy intersection or to disable certain features when a school lets out. It's just smart. Of course, the ultimate retreat is handing control back to the human. But this isn't some chaotic, sudden event. It's a super structured, legally required process. When the car knows it's reaching its limit, it sent out alarms. But here's the key. It doesn't just shut off. It keeps driving safely for at least 10 seconds. That gives you, the driver, time to get your head back in the game. And if for some reason you don't respond, the car performs a minimum risk maneuver, like slowly, safely coming to a stop in its lane with the hazards on. So you've got these two totally different approaches, right? The spear, which is all about pushing forward, and the shield, which is all about setting boundaries. So let's put them right next to each other and see how they stack up. This really lays it all out, doesn't it? The spear's goal is always to improve performance using things like sensor cleaners and smart algorithms. The shield, on the other hand, is designed to intentionally limit performance when things get risky, using things like torque limits and handover rules. You see, a truly safe autonomous car doesn't just have a really sharp spear, it's also got to have an absolutely unbreakable shield. They need each other. And this really gets to the heart of the challenge for every single engineer working on this stuff. It's a constant balancing act, a balance between that aggressive mechanical intelligence and a cautious engineered humility. If you had to boil this whole thing down to one sentence, it would be this: make what's possible better and make what's impossible safe. You use the spear to push the limits, to make the car better and safer in the conditions it can handle. And you use the shield to build a safety net, to gracefully handle all the situations it just can't. So that leaves us with one final question to chew on. As these cars get exponentially smarter, what's going to be more important? Will we need an even stronger spear, one that can handle almost any problem? Or will we need a much, much smarter shield, one that has an even deeper, more profound understanding of its own limits? The answer to that is probably going to define the future of how we all get around.